Okay, so to review this correlation idea again, just make sure you've got this. Now you can see all three together. Positive correlation goes up from left to right. Again, overall going up left to right. Now I know this doesn't make a line, but we're going to create that whole the line of fit. Negative correlation goes down from left to right. No correlation, just scattered all over the place. You can see them next to each other now. Maybe that'll make it a little clearer for you. Alrighty, so making a scatter plot and describing its correlation. So first thing we do is we plot points. So again, make a scatter plot on that. So I gave you my my steps. Let's bring those back up to you. So here you go. Again, notice mine here. After you plot all points, so plot the points first. So make a scatter plot. Treat the data as ordered pairs. For the altitude of 1,500 meters, the temperature of 55.5 meters, plot 1,500 and 55.5. So 0, 59, right? Right up here. 500, 59.2. So go over here to 500 and up to 59.2. And go to 1,000, 61.3. So 1,000, 61.3. You can see those here. I'll even zoom in just a hair for you so you can see them better. There you go. So it's all plotted. Now you might notice first off, before you go ahead and make your line, this is going to be a negative correlation, which is a negative slope. That's what correlation really is looking at. Sort of a slope you're going to create, right? So let me zoom back out here. So you've plotted all the points correctly, and make sure you do that. Notice in order to accomplish that on this one, we had to go by. Notice here that again we had to go by 500s on the x's and go by 10s on the y's to make that happen. Otherwise, it wouldn't have fit. So we can adjust. We can do that. So make sure if you decide to count slope, right, that each x is 500, each y is 10. Keep track of that. You don't want to lose track of that. So, what type of relationship does a scatter plot show? Well, in this case, temperature outside a plane tends to decrease as the altitude of the plane increases. So again, notice this is altitude. This is temperature. It goes down from left to right. So as your altitude goes up, your temperature goes down. That's a kind of question I'm going to ask you on a quiz and test. So I might go, okay, so you've plotted the points. Is it a positive or a negative correlation? You're going to say negative because it goes down left to right, just like slope. Then I know we'll get to that. We're not doing that right now. Then we'll make our trend line to go with it. So, so there you go. Anyway, plot the points. This one, negative correlation. Again, I know it doesn't make a line, but you could make a line overall if you really wanted to. And let me show you what that might look like. And since we use slope-intercept form, you might want to start flat out with a good intercept. And you can even see the intercept here on this one is exactly at 59. 0, 59, right? 0b, we've talked about that form out of a line, the slope-intercept form. And so you might actually start there and draw something that looks like this. And it doesn't actually have to go through any of the points. Just overall, kind of go the direction of the points, sort of through a lot of them. And I'm going to draw one here. Right? Now again, it's tough to do it on the screen and make a straight line. You can kind of see, let's imagine that's a straight enough line. But again, you can start with that 060, where obviously we have the 059 rather, we actually have that point, there we go. And pick another good point along there. There might be like this one, and that's an easy point to read. 510, or 5010 rather. So the other point is 5010. And from that, you could count slope, right? You could calculate slope, and then you could write a line using the Y-intercept 59.0. Again, we'll do all that in just a minute, though. Go ahead and pause, head into class kick. I've got one for you there. Okay, so I've got one here for you. This is straight out of the advanced book, by the way. Make a scatter plot of the data in the table below. What type of relationship does a scatter plot show? So I'm going to graph these points. We're going to go from 10 on the x. Let's see, what is our smallest x? 4, right? So these are in no particular order. 4, 1.1. And our biggest is going to be 10, and 10 has two different ones here, right? So we know this is not a function, but again, be able to make a line out of it's the idea. So I can decide what's my scale going to be. I'm going to go all the way to 10, and what do I? 1, 2. I've got plenty of room here. I can go all the way to 10 here. On this side, we're going to go all the way up to what's our biggest? 2.8, right? So if you want to make these 0.5s, you really could get away with that. Be 0.5, 1, you make them all kinds of different things. So notice on the answer key here, they went by halves. So I'm going to do that same thing. On the bottom, though, I'm going to go by 1s, I think, on the x's. So there, I went and fill in the numbers for you real quick so you can see where we're going with that. Now we just go ahead and plot them, and I'm going to do that, and I'll pop them right in here just a second. There's the first one, 10, 2.5. There we go. So I plotted all those in there. Again, one at a time, right? We did 10, 2.5, 11, 2.8. Again, we treated the dollars spent as our X's, and we treated the gallons bought as our Y's. So made ordered pairs. We just graphed them. And you can see overall here, so the question is what type of relationship? Overall, we can see a very positive correlation. And later on, we'll decide, well, you know, what line could we write that kind of describes it? So we'll get to that part later. But again, an overall positive correlation once you graph those. And I include the actual answer key here. Part B, consider the population of a city and the number of letters in the name of the city. Would you expect a positive correlation, a negative correlation, or no correlation between the two sets of data? Okay, so again, listen to the question. Population, number of letters in the name. Those have nothing to do with each other. Nothing at all to do with each other. So you'd be like, no correlation. Probably all over the place. It'd be kind of fun to see that plotted somewhere, but it would be all over the place. Go ahead and continue for more examples from me. So again, I brought these steps up just to remind you. After you plot all the points, which we just practiced at, find a good Y-intercept point. Hold your ruler over it and find, again, a good point. This should one that's easy to read, not some weird decimal or fraction. Again, that's the point 0b. There's a reason I bring that up. Find another good point that is kind of in the middle of the other points. Again, this should be a point that's easy to read, not some weird decimal or fraction. Go back and find your slope. Count, or I should say, or calculate the slope. Write your line in the form y equals mx plus b. Super easy. We're going to do it. So let's get started on this. Writing an equation of a trend line. So first thing you do, plot the points. So notice here my points. Again, we're going to make this on the left side the x, the right side the y, and these are nothing more than ordered pairs. So 1, 2.5, 2, 7.6. Now again, I know these are all decimals over here, but we're not actually probably going to use those as points in our calculating because it's a trend line that we're looking for here. All right, so plot all those. 1, 2.5, 2, 7.6, so on and so forth. Plot them all. It's not a bad idea when they're in order to do that. We can see once they're plotted that overall, this is a really good line, right? A positive correlation, a good line of fit. I'm not sure I agree exactly with their line, but we'll mess with that just a little bit. So what is it they're doing, by the way? We've got age in months and weight in pounds. I would argue that 0, 0, right, is you're not going to go to negative weight. So 0, 0 might be a good place for our line to begin. Let me zoom in here just a hair so we kind of take a look there. So here's my line. I'm going to write a different line because they use some points that are just kind of ugly. Notice here. Notice right here, they use 17.1 and 37.9. Yeah, it hits those lines it goes through, but those are kind of tough to deal with. So I'm going to try to pick something that's a little less mathematically ridiculous. Okay, so I'm going to say, well, if your baby's at 0 pounds at 0 months because it's not born, right? I like that one. Now you can go into negative if you want to because their line kind of does that. And then I might pick another good line that it seems it kind of fits, right? So I'm going to do that. As I go along here, going along. If I were to, I'm going to hold my rule over. You can't see that part because the video doesn't let me show that. But it looks to me that if I were to draw a line that goes through, what do we got here? 11 and 48 as I'm holding my ruler over it. Let me show you what that looks like. Or even out here, we've got 12 and, what do we got? These are going by 6s, right? So 12 and 52. Do apologize, I misspoke. This would actually be 54 up here. Whoops. 50. We need an eraser now. There we go. This would actually be up here, it'd be 54. So the point I'm looking at out here, right, is the point at 12, 54. And I'm going to draw a line to match that just a second. There we go, made mine green. Notice it's really close to theirs, but mine's one easier math on it. And I'm telling you, with what we're doing here, you know, it's really what we're looking for. And I know you're not gonna all make the exact same line I do, but I'm looking at overall. Does your slope pretty close? Is your y-intercept pretty close to what I picked? That's what I'm looking for. Let me zoom back out on this real quick. So now, again, their math's going to be different than mine, so I'm going to pick mine. I'm going to show you my work instead. So here's what this looks like. Just a second, and I'm gonna give a blank slide here so I can show the actual work of writing the line. Okay, you ready? First off, we have to agree though, before I go anywhere, that this is a positive correlation, so a positive slope. I'm going from the point 0, 0 to 12, 54. So what's this look like? Well, remember, we're going to make a line in the form of y equals mx plus b, where that b is the point 0b. That's my y-intercept. Well, lucky for me, my y-intercept was 0, 0. That's the one I picked, and it looked pretty good, according to the line that I was going to draw to match all this. So that means that's going to be y equals something x, well, plus 0, right? Because there's that 0 right there. Well, what's my something? My m is going to be calculated from my slope, my counting of my slope. Let me bring that back in here real quick so we can actually count that slope. Now again, if you wanted to use that formula, right, m equals y2 minus y1 over x2 minus x1, or you can count the slope in this case, and that's what I'm going to do. Remember, changing y, so we go up from 0 to 54. So that's going to be from 0 to 54, so well, that's 54. Whoops, I need a pen, there we go. 54 over change in x, which goes from 0 to 12, which I do need to reduce that. You can go by 2's if you want to, however that works out. So in the end there, I'm going to get 9 over 2 for my slope. So that goes right in here, 9 over 2. So my line is really y equals 9 halves x. And if you look at the line they wrote y equals 5.2x, which 9 halves, right? What's 9 halves, right? So we have 9 divided by 2, we have 4.5. That's not too far off from theirs, and they have a negative slope, or a negative y-intercept, which is fine according to the line they wrote, but that's not the line that I wrote. So, and you might have a very different line. You might end up with 5x because of the line you wrote, plus, negative 1, or plus 0, 2 if you pick the same 0, 0 to start out with. But again, I'm looking for lines in the general vicinity. Notice overall, going up left to right, and the slopes are pretty daggone close, and the y-intercepts are pretty daggone close. That's what we're looking for. We'll do some more, don't sweat it. Okay, so your turn, go into class kick, do the same thing. Look at those steps as you go though, please. Don't be afraid to ask questions. Raise your hand if you need me to give you some pointers. I'm right here. Do it. Okay, I'm gonna try something on this one. Notice I brought in a ruler. I snapped a ruler and I cropped it out. I'm hoping I can kind of hold that over as I show you, as I try to design or just try to show you what that line looks like. We'll see if that works out or not, so this will be kind of fun. So make a scatter plot. This is one you should have done. Again, if you ask questions, if you need my help. Make a scatter plot of the data below, draw a trend line, and write its equation. What is the approximate body length of a 7-month-old panda? So we can use it to make predictions and things like that. All right, so let's get started. We're going to graph here, and we're taking a look at the x's versus the y's, age versus body length, right? Age, we can definitely go by ones. There we go. 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. Well, I didn't even go in order, did it? And then body length. So we got to figure out, well, we can go by ones, it looks like, on age here. So that'll be our x's, right? And our y's, let's go by 5s, shall we? Because we have to go all the way up to 30, it looks like. So I'm going to arrange this here real quick, the graph, and we're going to write on it, and we're going to see what happens. So let me slide this up and out of the way. And again, our x's this time, and I'll plop those in here just a second. So here we have our x's or age, and yes, I'm going by ones. I labeled the 2's though because it's easier to fit. And our length, our y's are going by 5's, but I labeled 10 because again it's easier to fit. So let's go ahead and graph those points. We'll start with 1 and 8. So we'll plop that in here. I'm going to switch colors. Let's go with blue for the fun of it. So 1, 8 is going to be about right here. Right, there we go. 2, 11.75. So 2, 11.75, about right there. Okay. 3, 15.5. about right there. And I'll go ahead and plop the rest here in just a second. There we go. And again, you can see them in the answer key too. If you didn't like my graphing right here, you can take a second, take a look at that. So, all right. So first off, we have to agree that overall this is a positive slope, right? Because it goes up from left to right. So there's my ruler. And here's what I actually do when I hold it over. So I figured that might be easier for you to see. Is I can, okay, well, we got to figure out where's that y-intercept going to be, right? And if I hold my ruler over it like this, and maybe another good point so you can see where I'm going with all this. It looks like my y-intercept might be about 5, 0, or 0, 5, I'm sorry. Almost said that backwards. And another good point it goes through might be up here at about, looks like 930, right? That's really daggone close. So if I were to make overall, so I'm going to make these in red for you. Okay, let me slow down a little bit with my words for you too. I'm going to say overall, it looks like somewhere in the neighborhood of 0, 5 and 930 are going to be my 2 points when I hold my ruler over it. And I'll plop those on here for you just a second. So there's those 2 points, and I put them in green for you. And if I go take a look here, if I follow it, yeah, that looks like it follows it pretty good. It's not too bad. It hits through some of the actual points themselves and goes overall, kind of fits the slope. So, again, I'm going to make a blank screen here. Let's agree first off that my 2 points are the points 0, 5. Notice there's that 0b, right? My y-intercept, and the point 9, 30. Those are the ones that I picked. You might have picked something different. I don't have a problem with that. Let's go to the next slide, and we're going to bring that in, and we're going to calculate the slope and make the actual line. All right, so here we have our 0, 5, our 930. So we know that we are using the form of the line, y equals mx plus b. Well, I know m is my slope. We'll count that or calculate that in a minute. My b is going to be this, my 0, 5, so something x plus 5. Now I got to figure out what is that slope. Well, my slope, if I wanted to count it, right, change in y goes up from 5 to 30. So if we wanted to use the formula, right, we have our 2 points here. We can make this point 1, this point 2. So instead of counting it this time, I'm going to calculate it, right? So we have to remember that our slope formula is m equals y2 minus y1 over x2 minus x1. And so that makes this right here x1, y1, x2, y2. So plugging in, we have 30 minus 5 over 9 minus 0. So 25 over 9, right, which is not going to reduce. And you could have counted that same slope. It goes up 25, right, and it goes over 9. So you could have easily counted that same slope. Alrighty, so 25, let's make 30 minus 5, 25, yeah, 9 minus 0, 0. So 25 ninths x plus 5. There's my line. Let's see what they had in the answer key. Let's check that real quick. So they had 2.23 plus 8.8. Well, 2.23, 25 divided by 9 is 2.7. That's not too far off. And 8.8 for the y-intercept is pretty close to, why did I put 5? Oh yeah, there it is. Yeah, there's my 5. So anyway, that's they put 8.8. I don't know if I agree with theirs, but again, it's just a trend line overall, and it doesn't fit too bad. So that's the one I'm going with. Now, that second part of the question, they want to know the approximate body length of a 7-month-old panda. So to find that, we would really just take and plug 7 months, because that's what our x represents, right? Age in months, back into here. And we've practiced that plug and chug before. So in other words, we would say, so y equals 25 ninths times 7 plus 5. And you can certainly do the math. Grab a calculator if you need to. So 25 divided by 9, 2.7777, right? Times 7 plus the 5, and we get about 24.4. Oh my gosh, look at that. That's exactly what they had. So our line, I'd say, is pretty daggone good. So 24.4 is going to be the length. So that's a pretty good line. I like my line better than theirs. Mine was easier to write than theirs. And then part B of that is, could you use your model to determine the overall length of a 3-year-old? Yeah, we're going to say no, because after a certain point, this panda is going to stop getting bigger, and I'll bet you 3-year-old's probably pretty daggone close to full grown, if not full grown. So it's not just going to keep getting longer forever and ever. That doesn't make sense. But anyway, we made a pretty good line, I think. Go ahead and continue for more examples from me. Okay, so one step farther than just a correlation is called a cause. Identify whether relationships are causal. In other words, one thing causes another. Like I get up in the morning and I eat like bacon every day for breakfast and I get fatter, right? Trust me, that's a cause right there. So, or I exercise and lift weights and ride my bike and I run and I lose weight. There's a causal relationship there. It causes it. Yeah, notice both those are related to, All right, so anyway, in the following situation, is there likely to be a correlation? If so, does the correlation reflect a causal relationship? The number of loaves of bread baked and the amount of flour used. Obviously, going to be a positive correlation. You're going to use more flour when you bake more loaves of bread. Is it causal? Well, yeah, because you use more flour when you bake more bread. It causes it to happen. B, the number of mailboxes and the number of firefighters in a city. Is there likely to be a positive correlation because both mailboxes, number of firefighters tend to increase as there's population. In other words, more people means more mailboxes. More people means more houses, which means you need more firefighters. However, installing mailboxes doesn't cause it. There's definitely a correlation, but it doesn't cause, mailboxes don't, oh look, they put up 10 mailboxes, so we had to hire more firefighters. Doesn't mean the mailboxes caused it. The population is probably what caused it. Couple of quick ones for you to talk about or to answer rather in class kick. Type in your answer, handwrite it, I don't care. Go ahead and head on in there. So your answers here for this. In the following situation, is there likely to be a correlation? If so, do you think it's causal? And explain. I'm looking for the words there, folks. The cost of a family's vacation, the size of their house. Now, obviously, there may be a positive correlation. People spend more money on vacation, they probably have a fancier house because they have more money. So, but the vacation does not cause the size of the house, but there's probably a positive correlation there, and you can read the answer down here. Part B, the time spent exercising, the number of calories burned. There's definitely a positive correlation. More you exercise, you burn more calories, and that flat out is also the cause, right? Exercising causes you to burn calories. It is a causal relationship.